In the next section, we are going to look at how to synthesize carboxylic acids. And I believe that the majority of this is review, or all of it is review. There's only one reaction that I am not completely sure that we haven't already covered. And there's either going to be one new synthesis of carboxylic acid, or none, if you've already seen it. So, first of all, I think that the first carboxylic acid synthesis that we ever looked at was primary alcohol, oxidation, down to carboxylic acid. You can do this with potassium permanganate, which is preferred. Why don't you just take it from him? Sorry, Benny is misbehaving. So potassium permanganate will oxidize primary alcohol to a carboxylic acid. If it's a secondary alcohol, it's going to go to a ketone, so this isn't going to work. Secondary. You could also use sodium dichromate in sulfuric acid. But since it's a carcinogen, it's not going to be the preferred reagent. Another synthesis that we learned was oxidation of oxidative cleavage of an alkene. You can have, depending on what kind of alkyl groups you have on an alkene, you can cleave them with concentrated potassium permanganate. And if you have on one of the alkene carbons an alkyl group and a hydrogen, like we have on this case, that fragment of the molecule is going to turn into a carboxylic acid. The other half of the molecule is, in this particular case, just going to make a ketone. We also, in the Alkynes chapter, chapter 9, saw that you can cleave an alkyne by ozonolysis. And it will break at the carbon-carbon triple bond, and both fragments for an alkyne will end up carboxylic acids. You can also accomplish this with concentrated potassium permanganate. Last quarter, we saw that you can, if you have an alkyl group attached to an aromatic ring, it does not matter how big this alkyl group is or what it is, even if it's another benzene ring, you can do what we call a side chain oxidation of that. You can use potassium permanganate. You can use potassium permanganate for, it seems like, just about anything, and this needs a little bit of heat. And it chops it, no matter how big that alkyl group is, it chops it all the way down to a single carbon carboxyl group. Again, this could be even just a big giant, like a benzyl thingy hanging off of here, and it's going to chop it all the way down. Or you could also use sodium dichromate. And one that we did cover but perhaps didn't use a lot, so maybe you've forgotten about it a little bit. A Grignard reagent, RMG, we're just going to say X. If you react it with carbon dioxide, of course, in ether, so that the Grignard doesn't die, you will get carboxylate. And then you can protonate that with just about anything. You could even probably protonate it with a little bit of water or a dilute acid or something like that, and you end up with carboxylic acid. That is one that we covered, although we didn't talk about it a lot, so that may seem new. And then last but not least, this one possibly is new. I don't know for sure that we've learned this. You can take a nitrile compound that has a cyano, carbon-nitrogen triple bond group on it, and you can react that with a little bit of acid dilute in water, and it will hydrolyze it to a carboxylic acid. You can also do that under basic conditions, like that. And keep in mind, because we haven't yet studied nitriles, we've talked about them a little bit in chapter 19, but not a whole lot yet. They come later on towards the end. Well, we are towards the end. One of the next 2 chapters. So keep in mind that you can synthesize a nitrile by taking an alkyl halide and reacting it with some kind of cyanide, like sodium cyanide or potassium cyanide, and you're going to get the RCN from that. So if you're looking at maybe homework problems where there's multi-step, RCN plus NaCN, for example, let me just write one down. Let's say you have something and it looks like this. Like that. You're going to end up with, at the very end of it all, carboxylic acid. So there are a whole bunch of ways to make carboxylic acids. Almost all of them review. Possibly, pretty sure this one is new. Make sure that you are remembering all of them and adding this one to your flashcards. And next we're going to talk about the reactions of carboxylic acids.